Welcome to CognitionChunks. This is your life a random variable? Existentialism meets math. Exploring types of randomness in mathematics and real life. Types of randomness in mathematics and real life. Introduction. Randomness is a concept that pervades various fields from mathematics and computer science to biology and philosophy. While many associate randomness with disorder or unpredictability, its manifestations are not all alike. Different types of randomness have unique characteristics, implications, and applications. This article aims to dissect the myriad types of randomness present in both mathematical theories and everyday experiences. Types of randomness. Pseudo-randomness. Definition: generated by deterministic algorithms, but statistically appears random. Applications: used in computer simulations, cryptographic systems, and data sampling. True randomness. Definition: unpredictable and lacks any pattern, often generated from some fundamentally random physical process. Applications: used in secure cryptographic systems, random sampling in statistical studies, and gambling. Quantum randomness. Definition: randomness derived from quantum mechanical phenomena, such as the decay of an atom. Applications: quantum cryptography, random number generators in quantum computing. Stochastic randomness. Definition: randomness that can be modeled using stochastic processes, often involving multiple variables. Applications: predicting stock market trends, weather forecasting, and modeling the spread of diseases. Algorithmic randomness. Definition: a sequence is algorithmically random if it cannot be generated by a shorter algorithm than itself. Applications: computer science, data compression algorithms, and theoretical mathematics. Chaotic randomness. Definition: appears random but is deterministic, sensitive to initial conditions. Applications: climate models, fluid dynamics, and cryptography. Environmental randomness. Definition: randomness introduced by environmental factors or noise. Applications: communications, electronic devices, and neural networks. Mathematical theories. Probability theory addresses the likelihood of different types of random events. Information theory quantifies the amount of randomness. Chaos theory investigates deterministic systems that appear random. Real-life implications. Randomness in decision-making, role of randomness in human and animal behavior. Randomness in nature, occurrence of randomness in natural phenomena like genetic mutations. Randomness in technology, importance of randomness in algorithms and machine learning. Conclusion. Understanding the different types of randomness is crucial for various applications, from secure communications to scientific research. By categorizing randomness, we not only understand the world better but also make more informed decisions in domains relying on unpredictability. Alternative perspectives. Determinism versus randomness. Some scientists and philosophers argue that there is no such thing as true randomness, that every event has a cause, however imperceptible or complex. This view challenges the notion of randomness as a fundamental aspect of reality. Human perception of randomness. Often, what we perceive as random is a result of our limitations in understanding complex systems or sequences. This viewpoint suggests that randomness is more of a human-made concept to explain things that we can't yet fully comprehend. This topic allows us to grapple with the complex interplay between order and chaos, determinism and freedom, as well as practicality and abstraction. Understanding the types of randomness could pave the way for advancements in science, technology, and even our understanding of the universe. Was this accurate? Did GPT just make up a bunch of stuff that does not exist or does not make sense? Is GPT dropping wisdom pearls, or merely soap bubbles? Tune in for the next CognitionChunks episode to find out. Remember, existentialism urges us to confront the inherent randomness of life, to take responsibility for our choices, and to carve out our own meaning in a universe that is often indifferent or even hostile. On the flip side, mathematics, particularly probability theory, gives us tools to quantify, understand, and even predict the randomness in various systems. While existentialism can often feel heavy with its weighty questions, mathematics provides a sort of solace, an almost poetic structure within the chaos. But here's the twist: if we can use math to predict randomness to some degree, what does that say about existentialism's claim that life is uncertain and without predetermined meaning? Is it possible that they're two sides of the same coin? Perhaps understanding one can illuminate the other. Before we sign off, here's your chunk of cognition to nibble on until our next episode. If life's variables can be calculated and predicted, does that diminish or enrich your personal quest for meaning? Do you see yourself as a random variable in an equation yet to be solved, or are you the constant, providing structure to the variables around you? As always, if you enjoyed today's episode, don't forget to hit that like button, and consider subscribing if you haven't already. We have a lot more thought-provoking episodes on the horizon, where we tackle the big questions with a sprinkle of nerdiness and a dash of humor. So, was our exploration accurate or just a bunch of theoretical mumbo-jumbo? Feel free to share your thoughts in the comments below. Join us next time for another hearty serving of knowledge, right here on CognitionChunks. Until then, keep chunking.